Hi everyone. Today I'd like to talk about the measurement of dissolved oxygen. So in your book on page 464, I'll take you through the theory about measurement of dissolved oxygen. Although oxygen is only slightly soluble in water, aquatic life cannot exist without dissolved oxygen. Some species of fish can survive on an oxygen concentration as low as 3 parts per million, but others need higher concentrations. The dissolved oxygen present in a water sample can be measured by an iodine thiosulfate titration using the Winkler method. So the next few bullet points looks at the reagents and how they react, and ultimately how dissolved oxygen can be calculated. So it's not really important that you understand or even remember these individual reactions, but it does help to explain ultimately how the calculation is done. Okay, so I'll just take you through it, and then I'll just highlight what you actually need to know from the next paragraph that I'm going to read. Under alkaline conditions, manganese 2 sulfate produces a white precipitate of manganese 2 hydroxide. So this is one of the reagents that's used in an actual titration, manganese 2 sulfate. This supplies the manganese ions. When the manganese ions react to give manganese hydroxide, then we'll look at the next reaction. This is then oxidized by the dissolved oxygen in the water, forming a brown precipitate. So the manganese hydroxide reacts with oxygen in the water. That's what we're trying to measure. And that gives MnOH2. The mixture is then acidified with concentrated sulfuric acid. Under these conditions, the manganese 4 oxidizes iodide ions to free iodine. So the precipitate formed up here under acidic conditions reacts with iodide ions to release free iodine. The free iodine is then titrated with standard sodium thiosulfate solution in the usual way. We've done iodine thiosulfate titrations before. It's the one where we use starch as an indicator. So you'd be familiar with that type of titration. The iodine that was freed then reacts with the sodium thiosulfate. So where does the oxygen measurement come into place then? Well, basically, the oxygen liberates iodine. The more oxygen that's present in the water, the more iodine will be liberated. And then by titrating the liberated iodine, we can then work out how much oxygen was there originally. Okay, so the oxygen liberates the iodine, and by seeing how much iodine has been liberated, we can then work out the oxygen that was there to begin with. Now, with all these reactions, it's important then just to summarize that overall. You know, when we use our M1V1 over N1 equals M2 by V2 over N2. So how many moles of oxygen react with how many moles of thiosulfate? Well, overall, the ratio of dissolved oxygen, the number of moles of dissolved oxygen that react with the number of moles of thiosulfate is 1:4. So when you summarize, when you put all this together, you get 1 mole of oxygen needs 4 moles of thiosulfate ion. So that's the N of oxygen, and that's the N of sodium thiosulfate. You will see where that comes in and why that's important in the calculation for the titration. And I will explain that in another video. Okay, that's it for the theory.